Hi, Matthew.
Hey, Emilia, what would you like to work on today?
I think let's just continue with 7.2.
Okay, I'll pull up that section and see what we got going on there. Do you remember any parts of it that were any sort of direction here? Just kind of go through the PowerPoints again.
Let me pull it up. 7.2. Well, I thought I was fine with like the U-substitution stuff. I mean, we could start obviously with that. But then the definite integrals is where I got like confused. So
Okay. Yeah, let's I think maybe you'll see some U-substitution problems that really could challenge you. That's a lot of students need extra help on that. And then definite integrals just add this sort of part of like, okay, we're gonna now evaluate the endpoints. It also looks like there's trig substitutions. That's more advanced topic. Do you know if that's covered in more than one example?
let's see.
That's on like slide 12.
Oh yeah.
You may want to find out if that's like going to be something you're going to have a lot more of, because that's a pretty.
I mean, he was saying that we need to know those, so.
Usually taught in calculus too. That's why I'm asking. To just be aware that it's a little bit unusual.
Okay.
So let's just start with something pretty straightforward here, like e to the 4x squared. Actually, let's not even do that. So e to the 2x dx. This is here's what you know. You know that the integral e to the u du equals e to the u plus c. Okay, but this is not in that form. And your u is 2x. So kind of off to the side here, what are your u substitutions? They are generally things that are exponents, things that are in parentheses.
In the parentheses or under the or square root.
Yeah, roots, denominators, but it's all kind of a guess.
Right.
And if you guess right, you leads to a simpler problem. It's about turning something that you don't know into something that you do know. So you know how to do e to the u, but you don't know e to the 2x. So you always take this derivative, and then you back substitute. So you obviously substitute for u, and then you solve this for dx. So dx is du over 2.
Du isn't it just the derivative of u, right?
Yes.
Okay.
So you always write du on the left. On the right, you take the derivative. It's just why all that first semester stuff was so important to remember. And then there's always a dx, because the derivative of x is dx. Okay, so now this one that we've come up with here, 1/2 e to the u du, this is now one that you know. You know that this is the antidote of this is e to the u. So it's e to the u plus c. That 1/2 comes down. But then, very important, you have to back substitute your u. Your u was 2x.
Right, so it's 1/2 e to the 2x
plus c. Yeah. Okay, so let me find some more difficult problems now. We've kind of have the feel for like what this is. There's some really good ones out there. U-substitution. Yeah. Okay. So let me actually go find one here. Okay, so let's say I want you to find the integral of 3x squared square root of x cubed plus 5 dx. This is kind of your exam quality question potentially. What do you think the u should be here? What's your best guess when you look at this?
X cubed plus 5.
Yes. Now a couple things. When you take your derivative should be somewhere else. Like it should kind of be in there.
Right.
It's kind of a helpful thing. So
then it's the integral of du.
well, I leave that in there. I would go 3x squared, square root of u, and then like you only substitute in for the stuff you know. So in this case, you know, x cubed plus 5 is u, and then dx is du over 3x squared. So this is du over 3x squared. So these cancel. And I like to show that because then it's much more understandable, I suppose.
Okay. So
This is power rule.
and then you do, well, don't you substitute now back in?
No, that's you don't substitute until you're done integrating. So you need to integrate. Like the whole point of this was to turn that more complicated problem into this much simpler one. And you're just using the power rule. You're adding 1 to the exponent, dividing by the new exponent.
Okay. Oh, you're just doing the derivative of that.
Well, what do you mean? You have to integrate this. We have not done the calculus step. We've just changed the original one into an easier one.
Okay, so u to the 3/2 over 3/2
That's right.
du.
No, but once you've used the du goes with the integral. So once you've consumed it, once you've done this calculus step, it's gone. It's just u.
Oh, okay, so
this is 2/3 u to the 3/2 plus c. And then you have to back substitute. Your u was x cubed plus 5. So you take this and you put it in for u. 2/3 x cubed plus 5 to the 3/2 power plus c.
wait, so you just did, you just moved the 3/2 up, okay.
Yes.
And then, oh, and then you put it back in, okay.
Now, if you understood this or got this far, if we were to take the derivative of this, you should get back to the original. So the derivative of this is bring the 3/2 down, x cubed plus 5. You subtract 1 from the exponent. Then you take the derivative of the inside function, which is 3x squared. So do you see how these coefficients cancel? This becomes x cubed plus 5 to the 1/2 power times 3x squared. And if I go back to the original problem, it was the integral of 3x squared square root of x cubed plus 5 dx. See how that's there? The 1/2 is the root. It's the same thing. Okay, so if you think you understood that, let me have you try one here next and see if you see if this one is clear. And before I let you go too far, just let me know your u.
Okay.
U for this.
2 plus x to the 4th.
Yes. All right, so take it from here, and I'll catch up with you here in about 30 seconds.
Okay.
I'm gonna jump in and just write a few things. You can look up if you want.
Okay. I'm confused how you do the dx because I got the du.
Are you, you're asking how to take the derivative? Like this on the right here is the derivative. The derivative of 2 is 0 plus 4.
No, I got the du, but how do you get your dx? Like
You just solve for dx as if like this is a variable. You just divide both sides by 4x cubed. Like you divide by 4x cubed. And then you just switch the order
okay,
so that dx is on the left.
gotcha.
And again, if you've done this right, it almost always reduces to something that's one of the rules on your integral sheet.
Why? I don't understand why it's u to the 4th either. Why is it? It's
Oh, I'm sorry. There's a 5. That's a 5,
okay.
isn't it? I missed that. I'm sorry. That does matter. Not paying attention.
So then you just move the 4.
You don't have to rewrite u. You can just substitute it in.
I don't understand. So, okay, so it's x cubed, the integral of x cubed u to the 5th du over 4x to the 3rd.
Right. And so the x cubes cancel.
Oh, okay. X cubed.
They have to. Like when you make this u, your only variable of integration is u.
So then you have u to the 5th du over 4.
Yes. And
then,
my choice is to bring that out as a 1/4, just for making it easier to visualize.
okay, so then it's u to the 5th du. So then you bring in the u or no?
No, you have to, like when you get here, you have to take a derivative. You have to integrate. You're converting this first problem into this other one.
So you're doing like an antiderivative?
Yes, you're always doing
Okay.
it at this step. It's the same. The first step is to take the antiderivative to integrate, but you need to put it into a form that you know how to do.
Okay, so it's u to the 6 over 6.
Right, with the 1/4.
And then that's the plus c, and then that's 1, 4, 6. And then you bring that, okay, 120. So that's 2 plus x. Do you do 2 plus x to the 4th to the 6th, or just leave it like that?
You just leave it like that. You don't have to evaluate. You don't have to simplify.
Okay.
Okay, let's look at another problem here. Let me know when you get caught up on this. Yeah. Okay, so this time I'm putting some bounds in. We'll talk about that in a moment. What is your u in here? What say you on this one?
4 plus 3x.
Okay, so your du is, what's the derivative on the right?
Just 3.
3 dx. So if you divide both sides by 3, dx equals du over 3. Okay. Now this is very important here. You have a choice. You can either, option 1 is to no bounds. Okay, you just ignore them for the moment, or you can replace the bounds, and you have to decide here. So I don't know which, it wasn't clear from your notes what you did in class, if either. Do you remember?
I don't remember what those mean, so.
Okay, so like you can take this 0 and plug it in for x here. You can find u of 0, and then you can find u of 7, this top bound. My guess is you haven't done that yet.
I don't remember, honestly.
Okay, so we're gonna do it with no bounds. We're gonna do the integral square root of u, because 4 plus 3x is u, and then dx is down here. That's du over 3.
All right. Okay.
Okay, so now I'm gonna put 1/3 out in front, integral u to the 1/2 du.
Okay.
So then you're gonna use a power rule. So you're gonna add 1 to
One.
this. So it's 3/2 over 3/2, 1/3 out in front plus c. But it's not plus c. We'll talk about that in a moment. But is that okay? This step here?
Yeah.
Okay, so that
Not plus c?
it's 2/3 times 1/3. It becomes 2/9. And then your u was 4 plus 3x. So it's 4 plus 3x to the 3/2 power. And now you have to go back to the original bounds of integration.
Oh, so should you even write the plus c over there?
No, well, it's correct from this line down, but that's why you're really supposed to replace the bounds. You're supposed to put new bounds here and then new bounds here, but I don't know how it's being shown in class, so I'm just gonna go ignore that for now. It's not wrong, but it is better to rewrite the bounds, but maybe you're not ready to see that yet.
Okay, so 4 plus 3 times 7 to the 3/2. So that's 2/9 times 4 plus 21, so 25. 29. Oh wait,
So this is 5, like you said, it's 25 or 5 squared to the 3/2 power. And then you're going to manipulate the exponents here. So it's 2 over 1 times 3/2.
so 6 over 2, so 3.
3, so it's 5 to the 3rd, which is 125 times 2/9.
No idea.
Okay. And then over here, it's kind of similar. You get 4 is really 2 squared to the 3/2 power.
3/2. Okay, so that's 4 plus.
So it's the same thing. It becomes 2 to the 3rd because, like you said, it's 6 over 2. That's 3. That's 8. 2/9 times 8.
So then that's 16 over 9 on that side.
Yeah.
Um,
It's like 234 over 9. And 2 plus 3 plus 4 equals 9. So we know the top one's actually divisible by 9, which means you can divide it by 3 twice.
okay.
So it's
So
78 over 3. And then you do it again and you get 26 over 1.
So 26.
Yeah. So.
Okay.
So I'd like to show you this problem though with replacing the bounds now that we've got it worked out. And let's just kind of go with it here, not worry too much about it. Whether I want you to see though the power of it. When you put 0 in here, you get 4 plus 3 times 0, which is 4. And when you put 7 in, you get 4 plus 3 times 7, which is 25. So your new bounds become 4 to 25 when you integrate this thing.
Okay.
Okay. And so it became 1/3 u to the 1/2 du. So you would write it as 1/3, and then it was u to the 3/2 over 3/2 from 4 to 25. And it ends up being the same result. So some examples are easier to do this way. This one's a toss-up because you end up getting basically the same numbers. Sometimes it gives you an easier thing to work with.
Okay.
Okay, so let's look at some more.
Well, but how does that become any like easier? Isn't that harder because you have like bigger bounds?
Well, that's why I stopped, because this one actually didn't become any easier.
Oh, I see.
And sometimes they do, but it's not obvious until you go down that road.
Okay.
a lot of calculus after this class is about manipulation to make it easier.
Right.
Okay, so new problem here. I'd like to do a few more, as many as you would allow, because there's so many different examples we could do, but this is a different type. At first glance, what do you think your U should be?
1 over x.
Yes. Now, I don't know if you've seen this problem before, but you guessed correctly. The derivative of this is -1 over x squared dx.
Oh, I was right?
Yes. Yes.
Oh, I thought that was like the wrong thing.
No, and
Okay.
that's why we're doing this, because if you guess x squared, it doesn't work. You end up getting something that doesn't
Gotcha. Okay.
work out.
Wait, -1. Wait, isn't the derivative 1 wait, how do you do 1 over x? What's the derivative? I don't.
Well, it's x to the -1, so you're using the power rule.
Oh, so then it would be x to the like -2 over
Yes.
2.
Yeah. Yes.
Okay.
Well, no. It's bring the -1 down, x to the -1 power. So it's minus x to the -2 when you take the derivative.
Oh.
So you're at a good point in the course where you may want to refresh your derivative rules. You may want to have that table out when you're working on problems.
Well, so it's x to the, okay, so minus x to the -2.
Yes, which is
Yeah.
-1 over x squared.
Do you have to write it that way, or?
It will be preferred, yes.
Okay.
Because you wanna solve for dx. So you're gonna multiply both sides by minus x squared.
Okay.
So dx equals -x squared du. So this is the integral of secant, and then 1 over x is your u over x squared, because we don't have a substitution for that yet, but dx is -x squared du. And if you've done this right, if you've chosen the right substitution, your x will cancel. Now there's a couple of like exceptions to that, but we probably won't see them today, but they might show up on a test, so we'll get to them at some point. Here the x squareds cancel.
Mhm.
So you're left with negative integral secant u du. And if you've got
So you
that,
just brought that negative in front. Okay.
yeah, it's good. You get in the habit of doing that.
So then you do the antiderivative secant.
Yes. So do you have that integral table I might have sent you at some point?
Yeah, you sent to me yesterday.
Okay. Let
Open
me
this.
see. Let me see if this one's on here. It is. Now this one is not as nice. Like I wouldn't ask you as an instructor to like remember this one, but it is on the table as if like, hey, you should remember this.
Wait, is the secant the ln?
Yes.
Secant? Okay.
So it becomes minus natural log absolute value secant u plus tangent u plus c, but u is 1 over x because we made that substitution. So we've got to go back and back substitute. It's very often the case that students forget to do this, and you want to just always get in the habit of checking for that.
Okay.
All right, so let me get another one here. I haven't let you go down the path of guessing the wrong u, but if you're working on these on your own, like you could consider just like making sure you know the right u as like the fundamental steps. That's like really important to check before you go much further. So here, u, any idea what u is? Sorry, in this horrible integral.
Let's go. 1 minus x squared.
That seems super reasonable. So let me don't copy any of this down. So let me just carry this through here. So it's the integral sine inverse of x and square root of u and du or dx is du over minus 2x. So notice that the x's didn't cancel and there's still an x in here.
So it's not that.
That's not it. Okay. And this is one of those like really non-obvious, but the correct answer is that the derivative has to be in there, like when you take it. So if u is sine inverse of x, which I don't know how you would know until you've done a few of these, the derivative of sine inverse arcsine is one over square root 1 minus x squared dx. And see how that's in here.
Oh, so that's just like a one that you have to know, the 1 over x squared.
That's right. And there's a couple of those that are like in the list of derivatives, arcsine, arccosine, maybe arctan.
Yeah, I think what
And
was cosine is the one that's like 1 plus x
Yeah.
squared or whatever.
Yeah, and they sneak up on you. And all of a sudden you think, oh, I've got it, and you just misremember. So there's still a lot to do here, but dx is du times the square root of 1 minus x squared, because you're multiplying both sides by this. So it's the integral of u over the square root of 1 minus x squared, and dx is du times the square root of 1 minus x squared. So notice how those cancel, and it turns into the integral of u du.
Okay, so then you do, wait, how do you do the,
One power rule. It always goes down to something very basic, something you already know.
so then you do 1/2 of, what was our u, the negative or sine?
Sine inverse, and that's one of those things like, whoa,
To the
what
negative
was it?
1 x squared plus c.
Yes.
And then that is, wow,
That's
okay.
it. That's your answer. There's nothing else you can do.
Oh, okay.
All right. So what I was trying to say here is, and let me grab a couple of these. Well, I guess I've been picking and choosing here. So like, let's look at 7, 8, and 9 here. Let's just see if we can figure out the u's for each of them, because that's like an important skill. That's what I was trying to emphasize is it's really more important that you can figure out what the u is in each one, and then doing it is just a matter of manipulating it.
So pi, well, cotangent pi t.
So what is the derivative of cotangent pi t? or the derivative of cotangent?
Cotangent is like secant. No, that's a lie. I don't know.
So the derivative of cotangent is cosecant squared. The derivative of cosecant is cosecant cotangent. So this one actually, you were actually right. It actually is pi t. Maybe we should do this one, but
so just not the code. Okay.
yeah, this one's deceptive because the antiderivative of this as is just cosecant.
How do you do the du for pi over t though? So is it t squared over 2?
Pi dt. You're taking derivatives. You gotta maybe even write it, or go say going forward. You got to remember that you're doing derivatives now.
Oh yeah, okay.
So this first one becomes the integral cosecant u cotangent u, and then dt is du over pi. So it's 1 over pi integral cosecant u cotangent u. And if I snip in the reference for this one, oops, I'm on the wrong page. Let me get that. Sorry, I'm just getting a little slow here. Here it is. So the reference is right here. You can see that it is like this integral just becomes cosecant u negative. Yeah. So it's 1 over pi negative cosecant u plus c.
Because that's the antiderivative.
That's the antiderivative.
Okay.
And then you have to back substitute your u, and your u is pi t.
So -1 over pi cosecant
Pi t plus c. But if you remember, this one actually had bounds on it, so we actually need to evaluate it,
okay.
right? We're not going to, but
so would you not, like, is it not right to write pi like plus c, like from the -1 over pi cosecant pi t? Is that where you would do your
yeah, you would
don't
need to
write plus c there?
you would not write plus c in this problem because
Okay.
you eventually would back substitute and put
Right,
the numbers in. So like you have to, like, the difference between 7 and 8 is that 7 gives you a number and 8 gives you an equation, a family of curves,
Okay.
because there's no limits here, bounds of integration. So let's look at 8. Let me snip it in here. What is your u in this one?
X cubed plus 5.
Yes. Good. All right. So let's
And
go to
then
not.
the
Let's do it. Let's do the next one. This one's more interesting
okay.
because we've kind of already done a few like that. All right. So what is your u in this problem?
-x squared.
It is. Now this one let's work through. So it's du. You're taking derivatives. So you're taking the derivative over here.
So no. Yeah, -2x
dx.
dx
And dx is du
over -2x.
Yes. So we're going to integrate, and we're going to leave off the bounds because we made this substitution. Again, that might change for you when you go to class next day. But -x squared is e to the u. dx is du over -2x. So notice that the x's cancel, which is what we wanted. We can't have anything but u in there.
du over -2. So then you bring that out. -1 e to the u du.
Now it would be plus c, but we know that u is -x squared. Right, when you take the antiderivative, we normally write plus c, but we know our u, and we know this is bounds. So that's the danger of not carrying them through the problem.
So you just do the one, like at 1, at 0 here.
Well, it's e to the -x squared from 0 to 1.
Oh wait, I forgot you put the u back in. Okay.
Yes, you have to put the u back in. You can't just evaluate it at those points. It may, in some weird case, give you the same numbers, but
then it's -1/2 e to the -1 squared minus -1/2 e to the -0 squared.
So on the left here, this is 1 over e. So it's -1 over 2e. On the right, these two negatives combine. E to the 0 is 1, so it's 1/2. The more common way you would see this written as 1/2 minus 1 over 2e.
Wait, so e to the -1 is what?
1 over e.
1 over e, and then 1 e to the -0. E to the 0 is 1.
Right.
So it's -1.
No, this 0 is neither positive or negative, but you can put a negative in front of it if you need to. But it's just 0.
So it's just 1. Okay.
Yes. Yes.
So then that's -1/2 or -1 2e plus 1. Okay. And then is it plus c?
No, because you've already, if you have limits of integration, you get a number. When you don't have limits of integration, you get a plus c.
The c is like an unknown, basically, or like
There's a family of curves associated with the integral, and the c is what gives you all the different families of curves.
Oh, okay.
All right. Is it, can we keep doing these, or is there something else in this section you want to cover? Because these are pretty
Oh,
important.
just the, what was it called? The definite integral stuff, but
So this is a definite integral right here.
okay.
Okay, so all right. So what do you say here? What you look at this, take a moment, see if you can figure out what should your U be?
Sine x.
Okay, so let's go with it.
Okay.
So du is derivative of sine
Um,
is cosine.
yeah. So
So
then dx is du over cosine x.
So again, this is my preference. Like I don't start trying to substitute until I don't try to like cancel out things. I just throw it all back in, and then at the end cancel out. Like I mentally check off, okay, yeah, I got all those.
So the cosines cancel.
Yes.
So then it's sine u du
Okay. So what's the antiderivative of sine?
negative cosine
Now it's normally u, but u is really
sine
sine
x.
x, and then you can back substitute your limits of integration.
Okay, pi over 2 0. So then it's negative cosine sine pi over 2 minus cosine, or no, plus cosine because it's negative, sine of 0. And then that's negative cosine, sine of pi over 2, that's 1.
That's right. And cosine of 1, we don't know. We just call it that value.
Cosine of sine of 0 is 0.
Mhm.
So cosine of 0. Okay, so then it's cosine of 1. Wait, we just keep it like that.
Cosine of 0 though is 1. So you would write 1 minus cosine of 1 as your final answer.
Cosine of 0 is 1. Yeah, so then that's plus 1. So then 1 minus cosine of 1. Okay.
Okay. Let me have you try this one on your own, and I will add bounds limits of integration here. All right, so take a minute or two to work through that, see what you come up with. I'm just going to step aside for 30 seconds.
Okay.
Any questions about this one?
Is the u x squared plus 1? Because I feel like it's not
Yes.
working. Oh.
Yes.
So then your du is 2x squared dx, and then your dx.
Oh, no, 2x dx.
That's why. Okay. 2x dx. I see. All right. And then that's that. Okay, that works. I was like, the x's aren't canceling.
Yeah,
So
they
then
have
it's
to. They have to, right? Like
u
that's
over 2u squared. 1 over u squared du, and then 1/2 front. Okay, so then that's the antiderivative of 1 over u squared. So that's 1 over u cubed over 3.
So it's power rule. And what I was trying to show, I was going to show you here on the right is that we just did this. The derivative of 1 over x is minus 1 over x squared. So the antiderivative is going the other way. Now what I hear here is that you want to add 1 and divide by the new exponent, which is correct. But this is a time saver right here on the test. Seeing like, oh, to go backwards, I just got to put a negative in there, and then in the numerator. And if you don't see that yet, that's okay. But that's power rule. This is just x to the n dx.
Right, so
you just add 1.
negative 1 over.
Yeah, it's u to the negative 1 over negative 1. But because you're going to evaluate it, you don't want to leave it like this.
Wait, 1, oh, okay.
Because u to the negative 2, and then you're adding 1 to the exponent.
Right, but how did you do that box, whatever you boxed in? I don't understand that.
Okay, let me start it fresh, because I think that'll. So if I give you 1 over x, the derivative is negative 1 over x squared. Like eventually you just will be very comfortable with this.
Okay.
So if you're integrating 1 over x squared, which is what we have here, it's like going backwards. So it's not 1 over x, it's negative 1 over x, because there was a negative here, so the negative.
Oh, I see. Okay.
Yeah,
Gotcha.
and that's what this becomes. This becomes negative 1 over u. And the faster you can do this, I know we talk about speed a lot, and I'm not trying to I know this is hard when you see it for the first time, and it's great that you're doing this. I'm just trying to give you some ways to pick up time on the exam, because this happens over and over again, this sequence.
So then you do your minus 1 over the u was x squared plus 1.
X squared plus 1, but you got to evaluate that from 1 to e.
1 to e, okay. So then that's 1/2 minus 1 over e squared plus 1, and then minus 1/2 1 over 1 squared. So 1 plus 1, 2, 1/2 minus 1/2 is 0. So minus nothing. 1 over 2 e squared plus 1.
This one on the right does become 1/4.
How did I? Oh, wait, you combined the 1/2 minus 1 over u?
It's multiplying the whole time. Like the 1/2 just came out. So it's just multiplying.
I thought it was subtracting. Okay, wait, that's why this is wrong. So, okay. Negative 1 over 2 x squared plus what? Okay, let me try. Negative 1 over 2 e squared plus 1 minus negative 1 over 2 1 squared plus 1. So then that's that 1 minus or plus 1 over 1 squared is 1, 2 times 2 is 4. So then that's, and then you can't do anything with the 2e squared, whatever.
No, and that's sort of my style, is to leave it kind of not simplifiable.
Right. All right.
Okay, this could be our last question if you want it to be. I would love to see you work through this one on your own. It's got definite integral bounds. It's got a u that you're familiar with. This one works out super nice.
Is the u the 4x cubed minus 1?
Yes.
Okay, just make sure. 12x squared is your du.
Yes.
Dx, I mean, and dx equals du over 12x squared So then you do integral -12 x squared u cubed dx. I mean, no, du x squared. Those cancel. So negative integral of u cubed du. And then you do your antiderivatives. So that's u to the 4th over 4.
Right, so, but then you have to back substitute 4x cubed minus 1.
What happens to the du? Why?
It gets consumed as part of the integral.
Oh, okay, just one. Okay, so then you do your substitution back in. So then that's negative 4 x cubed minus 1 to the 4th over 4 at 1 and 0. So then that's, geez, okay, 4 times 1 cubed minus 1.
You want to start getting comfortable with 1 to the n is always 1. 0 to the n is always 0. That way you can just start writing, oh, that's 4 minus 1.
Yeah. But to the 4th.
Yes.
Then that's 3 to the 4th, which is
81.
3 to the 4th is 81. Oh, okay.
Yes.
81, but 81 over 4 negative, and then minus 0, because that's, so then negative, wait.
So you put 0 in for x cubed. It's
Oh yeah,
0,
negative
1 minus 1.
4 over 4. So then that's negative 81 over 4 plus 1/4. So then that's negative 80 over 4, which is negative 20. Yes. Okay.
Okay, now while you were working on that, I sent you the file that we've been working on. Someone put together a really nice U-Substitution practice. And what I really like is that page 4, it's not page 3, but like it has the U-Substitutions to verify. That is the key step. Like you guessed right almost every time, I think every time today, but if you guess wrong, you will never get the problem right.
Wait, page 4 is this one?
Yeah,
Oh,
so
okay.
we were doing page 3, but page 4 has the like, hey, here's the
gotcha.
in case you're
right. So it's not always the one that's like in the parentheses.
Right.
Like,
those are guidelines, right? General works most of the
that
time.
one that was like the sign or whatever, cosine.
Yeah, and you're gonna get some problems like integral, which we don't have time for, which is like x minus 1 squared over x squared, stuff like this, that they're kind of a little bit different. They're challenge problems. They call them the challenge problems there, but
so what would be the u in that one?
Well, it's x minus 1, but then you have to also solve for x.
Yeah.
So it ends up being a little bit messy, but don't worry about that. If you understood what we did today, you're really far ahead. This is actually the first topic they talk about in calculus 2 at universities. So that's the B. You're in the B part of the course right now. The AB, you're in the B.
Oh, cool.
All right. Well, that does take us to the end of our lesson today. I don't remember when we're meeting again, but I will see you then. All right. I will see you then. And thank you so much. Have a great day. Bye now.